right, my growth mindset math side maniac Panthers. Let's go. Okay, ratios. What is a ratio? A ratio. There are more things in the heaven than the stars that are in your mind. Or is it the other way around? That's kind of Shakespeare. We'll check it out. But in the meantime, the comparison of two numbers. This might actually be more confusing than what I just said a moment ago. A comparison of two numbers that depends on the division relationship between them. And sometimes it's called multiplication relationship. So just not to make it even more confusing, let's get into this. Let's try to clarify this. Relationship between two numbers. How about that? Oh yeah. Yeah. That just settles it all. It's crystal clear now. Not. Okay, said no one ever after Mr. Hoffman did this. Okay, well, let's see. Let's take a look here. How about, what do we have? Can we make two numbers out of this? What two numbers do you think you can make out of this? Yeah, you got it. 3 and 2. 3 dogs, 2 cats. So there's a relationship between those two numbers. The 3 and the 2. 3 dogs, 2 cats. So we say this is a ratio, 3 to 2, 3 dogs for every 2 cats. You can put it in fraction bar form, 3 over 2, as long as you know the 3 is representing the dogs and the 2 is the cats. Whoa, what do we got here? This is also a ratio. It's a ratio of 3 to 2, but you're saying, wait a minute, Mr. Hoffman, there's a lot more than 3 dogs there, and there's way more than 2 cats. Let's take a look. I think you're absolutely right about that. Let's draw, shall we? A 1, a 2, a 3. Oh, a 1, a 2, a 3. That's, how many is that? 3 and 3 is 6. A 1, a 2, a 3. That's a 9. 3, 2, 3. That's a 12. We have a total of 12 DOGs. 12 dogs. And by the way, you could flip this. You could start with cats and then do dogs, but of course, you just got to define it that way. That's all. We're going to define it with dogs first because I'm a dog guy. What can I say? I'm a dog first. I love cats too, but you know, I'm a dog guy. What are you going to say? So how many kitties? Let's do kitties in green. A 1, a 2. 2. A 1, 2. That's 4. 2, 4. Oh, I see a pattern. 2, 4, 6, 8. Ooh, 8 kitties. Kits. I'm going to put kits for short. 8 Kit Kats. But when we break that down, it still comes out for every 3 doggies. For every 3 dogs, how many cats do we have? For each 3, 1, a 2, a 3, a 1. Oops, a 1, a 2, a 3. How many catties do we have for each catties? Kitty catties. 1, 2. For every 3, we have 2. So the ratio is still the same. It's 3 to 2. The total is different because here we had a total of 1, 2, 3, 4, 5. And out of those 5, 2 were kitties. Did we do kitties in blue? We did kitties in green. And we're doing doggies in, so kitties in green, doggies in red. So it's 2 to 3, but the total is 5. So every 2 out of 5, even though, so that's 2 out of 5, but the ratio is 2 to 3. 2 to 3. I'm in red, so let's put 3 on the bottom, 2 on the top. Okay, but the total is 5, so you gotta be careful here. It gets kind of tricky. All right, but the total here is, well, let me see, how many are in each group? Total, we have 1, 2, 3, 4, 5 in each group. 5, 5, 5, 5. So we have 5 groups. 5 groups. And how many are in each group? 5. Oh, really? So that's going to be 25. 25 total. Okay. So what if we have this many kitties? How many doggies will we have? Well, what's the ratio? If the ratio, again, is 3 to 2, 3 doggies. 3 dogs for every 2 kitties. But kittens. We're all babies anyway. Puppies. How many dogs total will we have when we have this many kitties? Stop the video. Let's see. Find out. All right, what'd you come up with? Let's see. Well, you know, for every 2 kitties, we have to have 3 doggies. So I could draw 3 doggies, or I can just do magical things like press this button. Oh, 3 doggies. Another 3 doggies. How many is that? That's 3 plus 3 is 6. Another 3 doggies. 3, 3, 6. It's 3, 6, 9. Oh, I see a pattern. 3, 6, 9. 12. Oops, we're on 12. Here's 12. Here's what's after 12. 15, 18, and then a 21. That makes sense, because when we start from the beginning here, how many groups of kitties do we have? 1, 2, 3, 4, 5, 6, 7. And 7 times for 3 dogs for each set is 21. You can write this in many ways. If we say A is our number of doggies, and we say B is our number of kitties, we can write this as 3 over 2. It looks like a fraction, but it's not. We'll talk about the difference in a few moments. So here it is in words. You can also just say 3 to 2. 3 to 2. If you write the fraction bar, we already did that. 3 over 2. And then if you're going to write it with a colon, which is also very popular, for representing ratios, it would look like this. 3 colon 2. So think about it. All these ratios are 2 to 3. Wait, 2 to 3. Wait a minute. 2 is what? The kitties. If you do kitties. If you're saying that, what's the ratio of kitties to dogs? Then the ratio of kitties to dogs is 2, 2, 2, 2. Instead of Toto, 2, 2. Okay, that's a bad joke. But I love The Wizard of Oz. I can't help myself. Ignore the man behind the curtain, which is me sometimes. Green. Oh, not green. That represents kitties. Sorry. Nope, that represents dogs. 3rd time's a charm. So, again, just to be clear, the 3 represents the dogs, and the 2 represents the kitties. Here, that's the ratio of kitties to dogs. What if I said, what's the ratio of dogs to kitties? Well, then you just say 3 to 2. We just reverse it. So what's the difference between a fraction and a ratio? Fraction is a number. You can put it on the number line. Let's say this is 0. And we're going to do 3. Let's do 3 halves. Where would 3 halves go? This is 0. And let's say this is 1. This is 2. And this is 3. Aha! Well, half. This is 1 half. This is, so we'll put 1 half on the top. This is 1 half. This is 2 halves. Aha! This is 3 halves, which is the same thing as 1 1/2. Beautiful. So a fraction does have a place on a number line, right? So 3 halves does go on there, but when you're talking about a ratio, it's not a number. Remember, it's a comparison between 2 numbers. See, a fraction is just one number. But a ratio is 2 numbers. There are 2 numbers. So in many ways, some ways, I guess, in many ways, they behave exactly like fractions. So ratios are, we can use that to our advantage. Just be careful not to confuse the two, because they are not the same, but we can use it to help us. Very useful. Let's see here. I don't know why I have this. I just love it. The ratio. Beautiful stuff. Okay. 3 dogs for every 2 kitties. 2 kitties for every 3 dogs. Now, a fraction is part of something. So we take a sandwich, we say half. A fraction is just going to be half. I mean, there it is. That's what that represents in this case. It's one thing. But here, where you have this is one sandwich, right? 2 people. Here, this is just half a sandwich. There's this is just one number describing the sandwich. Here, the top represents the sandwich. The bottom number represents the people. Notice I didn't say numerator and denominator, because it's not numerator. That's reserved for fractions. Only fractions get that privilege, that honor, that recognition of numerator on the top and denominator on the bottom. So sandwich, one sandwich, and then 2 people. But coincidentally, if you did have this ratio, you divided it evenly, how many sandwiches would each person get? Oh, you guessed it, half a sandwich each. Can I draw half a sandwich? You get half a sandwich. They did kind of like that triangle half thing. You get half a sandwich. Here we go. Me. Words, 3 to 4. Fraction bar. This is probably my most intense one yet. Oh, my hand. Okay, but I gotta tell you, I'm trying my best here. I'm trying to do this with some pride, passion, and purpose, and with the time constraints considered. And then let's see if we weigh out the allocation cost of redoing this again. I think we're doing pretty good here, so we're gonna roll with this. Peace out, Panthers. Pride, passion, purpose as always.